Alright, so in this problem we have two blocks attached with a string, and we have to describe their motion, figure out some forces, and then do some kinematics. Alright? So the first part, right, we're asked a question about the acceleration of block B, and anytime you're asked about accelerations, you should be thinking about forces, and that means free body diagrams. So that's what I'm going to start with. So we have two objects moving, right? So in a system of objects, so we need two free body diagrams. Right? So block A is pulled to the right with a tension. It's supported by a table, so there's a normal force, and it has a weight. Right? We're told the tabletop is smooth, and so smooth means no friction. Block B is a little bit easier. There's a rope pulling it up, that's a tension, and it has a weight as well. So, that's our free body diagrams. Now, to figure out the acceleration, we need to write Newton's laws. And we know, since we're being asked about the acceleration, it's probably not true the acceleration equals 0. So for block A, it's accelerating horizontally, so I'm going to write about the horizontal forces. And there's only one horizontal force, it's the tension. Right? Block B is a little bit trickier, it's accelerating downward, so I have to talk about the vertical forces, not the horizontal. Right, these are completely separate for right now. Up we have tension, down we have the weight, and there. Okay, so now we have to check a couple things. First off, these tensions have to be the same because the string, we're told, is massless. Secondly, these accelerations have to be the same because the blocks move together. That's what it means to be in the system. So we have two unknowns and two equations so we can solve. I'm going to take this tension, what tension equals, and plug it right in there. So MAA minus the weight. And this is the weight of block B, right? I should make sure to clarify that in my free body diagram. And so the weight of block B is mg for block B. Right? And with that substitution, now I only have one unknown left. I just need to do some algebra to rearrange. Right? Getting all the acceleration terms on one side of the equation and getting everything else on the other. I factor out an A, right, so I'm going to move up to the top of the screen. Actually, I didn't have quite enough space for that. Let me try it over here. Oops. Now I flip the subscripts. Get it right eventually. Right, and as I get to this point, I realize that I've done something wrong, which you might have already noticed as I was describing this, but I think it's an instructive thing, so I'll leave it in. And that's the directions. Right? So in this equation, I've done something wrong. The tension, right here, the tension points up. The acceleration points in the opposite direction to the tension, right? Acceleration is down. So this really needs to be a negative A. Right, so negative A, and so then this is a plus, not a minus. Right? And so this is plus, and now we can solve. Right? So it's really important to pay careful attention to vector directions, right? That negative sign is because it's accelerating downward, so A has to be negative. Whereas in this one right here, to the right is positive, so A remains positive, right? You have to make sure it's all consistent. And now we have to look, and we know that block A's mass and block B's mass are actually the same. So this is A equals G times 1 over 1 plus 1. Actually, sorry, that's the sloppy way to write it. They're all the same mass, so it's M over M plus M. So M over 2M is just 1/2. And so we're left with A equals G over 2. Okay? Next, we're told block B strikes the floor and does not bounce. We have to figure out how long it takes to hit the floor the first time. Well, we just found in part A we have a constant acceleration, which means we can use kinematics, right? X equals x naught plus v naught t, right? That's our kinematics equation for constant acceleration. And I picked that one because it involves all the stuff we know. We're trying to figure out time, so it has to have time in it. We know the acceleration from part A, and we know the distance, right? Our problem says that it's a distance h above the floor. So x final is 0. It's on the ground. X initial, h. V initial, right, we're told it's released from rest, so this is plus 0. The acceleration is g over 2 downward, right? So it's a negative sign. And then we have a t squared, right? So we get, simplifying all this, we get 0 equals h minus g over 4 t squared. If we move stuff to the other side of the equation, we're going to get h equals g over 4 t squared, or t is the square root of 4h over g. Okay, so the next part is we have to do some descriptions in parts C and D. And so this is writing, right? This is not a calculation, this is writing. So I'm mainly just going to talk rather than write it down because it's hard to write on an iPad screen effectively. But you can't just calculate numbers, you can't just do equations, you have to be able to explain in words. So, block A from time t equals 0 to when block B hits the floor. We found the acceleration of block B in part A, but to do that we had to say that that's also the acceleration of block A. So from time t equals 0 to when block B hits the floor, block A must also have a constant acceleration, right? So it accelerates horizontally to the right with a constant value, right? A constant acceleration value. Its velocity increases, could be something you would say. But I think the keys are that it has to have acceleration, it's not a constant velocity, and it moves to the right. Right? Part D, now block B has hit the floor, but as you see from the rope lengths, block A is still a distance 2h from the edge of the table, so it hasn't gone off the edge of the table yet. But when block B hits the floor, what happens to the acceleration? There's no longer like a force from block B that pulls downward, right? The normal force balances the weight entirely, the tension doesn't. So there's no longer a tension force on block A. The tension is 0, which means that in this part of the motion, the acceleration of block A is 0, and it's at constant velocity. Right? It's important to emphasize two things. First of all, that the acceleration is now 0 because the tension is 0. And second, that it doesn't stop moving, right? Just because the acceleration is 0 does not mean the velocity is also 0. It moves, but moves at a constant velocity. All right, so part C and D are writing parts. Part E is a projectile motion question. Right? That's really what it is. Block A is going to slide horizontally off the table with some initial velocity, and we want to figure out how far it travels horizontally before it hits the ground. Right? So as a picture, what this looks like is kind of the following, right? Block A reaches right here and has some velocity v, and it travels in that parabolic path. right? Kind of like that. And what we really want to know, right? Block A travels that path. Block B has hit the ground like right here, right against the edge of the table. And what we really want to know is, what is this distance delta x? In other words, how far horizontally does it travel before it hits the ground? So we need to do a lot of intermediate steps for this. First, we have to know, what is that velocity v? Well, we know the time at which block B hits the floor, which is also the time that block A is accelerating for. And we know the acceleration, right? That's parts A and B. So v, let's just call it Vx, right? This velocity Vx that it leaves the table with is the acceleration times the time. The acceleration is g over 2. The time is going to be the square root of 4h over g. Right? Those are results from A and B, whatever we got there. Right? So we know the square root of 4 is 2, so we have 2 divided by 2. Those cancel. We have g divided by the square root of g, which leaves us with the square root of g. And so our answer is the square root of gh. Right? That's the horizontal initial velocity. Now we need to figure out how long the block is in the air. If you know how long it's in the air and how long it travels with this horizontal velocity for, I can tell you how far it goes. So how long is it in the air? Well, that's going to be another kinematic statement, right? This kinematics equation will be our best bet because we need time. So, where does it end up? On the ground. How high does it start above the ground? 2h, right? The top of the table is a height 2h. What's the initial vertical velocity? 0. What's the acceleration of block A as it falls? Well, now there's no longer a rope doing anything. It's just projectile motion. So the acceleration is negative g, and we have t squared. Right? So if we rearrange doing some algebra, we're going to get 2h equals g over 2 t squared, which tells us that t equals the square root of 4h over g. Right? This is TA in air. And finally, now we can put all these pieces together. We know it's horizontal speed, and it's time in the air, sort of how long it has to travel at that speed, and we want to know how far it goes. Right? So, plugging that in. Right? Will look roughly like that. And this simplifies really nicely. Of the square root of g divided by the square root of g. Those go away. The square root of h times the square root of h is h. So 2h. And so that is the answer to how far apart they are. Right? Lots of subparts in that question. But as long as you're careful and pay attention to how things move, not so bad.